When we go through our daily lives, we all perform many activities, such as drinking water, eating, watching TV, working, etc. But what we usually don't realize or think about is that everything in this world, everything that surrounds us, is filled with math. A great philosopher known as Galileo once said, "The laws of nature are written in the language of mathematics," and it couldn't have been said better. Math can be expressed in many ways, from height, length, percentages, years, fractions, etc. Math is the key to problem solving and is what makes us humans determine and surpass real life obstacles.
Our objective is that the functions that we can find in everyday life, like in magazines and newspapers, translate them into different mathematical ways. In this case, we're focusing on creating those functions into graphs, tables, text, and equations. And after that, we're going to choose one function to translate it into all of those mathematical ways. So our first function focuses on the word called consumption. On the following line graph, you see on the x-axis years from 1980 up to 2016. And on the y-axis, you see quantity of coal consumption in the world. This line graph focuses on showing that the increasing in years of coal consumption from 1980 up to 2016. This specific function could be found on a newspaper or magazine in the areas of economy and world growth. Why? Because coal is a resource and focuses on economy as well. On this line graph, our independent variable are the years, from 1980 to 2016. Why? Because they're changing. And the dependent is an amount of coal consumption increasing throughout the years. Why? Because the consumption changes as the years change. The domain on this chart is 1980, 2016, and the range is 0, infinite. Our second function is coronavirus cases in Mexico. So, on the following line graph, you see that it's labeled with an X and Y side. The X represents the number of days that have passed from February 15 up to April 21. The Y represents the number of cases in Mexico from these specific days. This function will be found on the health section on a magazine or on a newspaper. But nowadays, coronavirus is a pandemic, so you could find coronavirus cases in Mexico at international section or even worldwide. On this graph, the independent variable are the days we change, which is from February 15 up to April 21. Why? Because these days change. The dependent will be the cases in Mexico, because they change due to the independent variable that are the days. On this line graph, the domain is February 15, April 21, and the range is 0, 135,642,677.
So now it's function 3, which is employment newspaper newsrooms in the United States. For this function, it's a table from the year 2004 to the year 2018, which is the range, and the domain is from 37,900 to 71,640, and that's the range. And this function you can mostly found in the economic section of a newspaper, because this information is relevant to newspapers, offices, and investors due to the fact that it can impact their economy. And the dependent variable is the amount of employment in a newspaper room, and the independent is the years in the table.
Function number 4 talks about global water use. This function could be mostly found in the health section, seeing as water is the primary source for living on any living creature. Agriculture accounts for 70% of water consumption, with industries taking 20% and 10% for domestic use. Demand for fresh water is increasing by 64 billion cubic meters a year. 1 cubic meter equals 1,000 liters. The human population grows roughly about 80 million people per year, and by 2050, it is predicted that we will be a total of 9 billion humans. This graph can be mostly found in health newspaper because these statistics show troubling evidence that there could be less water for all humans to consume in the near future. The independent variable in this case is the years, and the dependent variable is the cubic meter per year of water withdrawal. The domain is 19,001 to 2009, and the range is 671,306 cubic meters to 1,386 million cubic kilometers.
So here we have function 5. In function 5 is the one we chose. So we need to have a graph, a table, and equation. So to do this, we selected the information from the table. Here are the cases and the numbers. And to show a graph and an equation, what you need to do is here you go to insert graphics recommended, and we chose this one, which is the one that showed the dots in the line. So when you have this, what you do is you double click on the whichever dot you want. I chose this one. Then you chose add a tendency line, and from these you chose your line that best represents your table, and then you show the equation, and you can also show the R, which is the R helps you with finding out if it's close to the dots, and whichever is close ones of this one is the one you want to choose, and it's closer to 0.99, so this one is the one I chose. So here's the equation, and here the graph. So now some important points will be that this is a graph of CO2 emitted from the year 1998 up to 2018. It shows increasing numbers of Mexicans. The value can change, and the function is a polynomial. And the dependent variable changes according to a dependent variable because of with more years there's more population, and with more populations there's more CO2. So the maximum value is 123 million, and the minimum value 99 million. And the domain is from 2000 to 2016, and the range is from 0 to infinite. This graph is always increasing, the years are discrete, and the amount of emission of CO2 is continuous. You can find this in a newspaper mostly on health problems because it can affect a lot of your health. Also, it contributes to global warming. And this is the best way to represent it in the three, because from every equation there was clear data. And we think that the table is the best way to represent it because it shows the exact numbers and the exact data we can then be used. And finally, to conclude this video, this project helped us a lot discovering different ways in which data is represented in our daily life. This project was a huge help because it provided us guidance on how to find equations in Excel and how different information is represented in a mathematical way on newspapers, magazines, etc. This project gave us more knowledge on how to classify information and understand it, and where to find it in our daily lives with no problem.